Hello and welcome to MAXSURF Webinar 6, Video 4 on probabilistic damage stability. The final step before analysis is to set up our stability criteria, which are used to calculate the S probability of survival. We first need to check within that criteria whether we want to use the older or the newer MSC code, and based on whether it's a passenger or a cargo vessel, enter the number of passengers, and for passenger vessels, wind heeling and survival craft heeling levers. Also, the ratio of maximum GZ to GZ and a range of heel angles on the GZ curve does require us to ensure that we have defined down flooding points so that those range of heel angles can be computed correctly. The way that we do that inside Hydromax is to open the criteria dialog as usual. If we're in probabilistic damage stability mode, just the PD criteria will be shown, and we have a choice of selecting the older or the newer code. The values should have been pre-filled from our global settings, so it's already set to a cargo vessel, and there will also be pre-filled values from the code for the max GZ limits and the range of heel angles. If it's a passenger vessel, so I'll change cargo to passenger, then if we scroll a little bit further down, we'll see that there's some additional data to be entered, and you'll see some cross-referencing of the passenger, wind and survival craft heeling moments. So if we look over to the tree on the left, we can see those three components of the criterion. If we look at the passenger one, the value for the number of passengers will have been copied in from the global settings, but we do have to enter in the mass of the passengers and the distance of passenger crowding from the center line. For the wind heeling, the default value of the pressure constant and pressure should be set up for you, but you'll want to choose whether you're going to use the computed windage area from Hydromax and add your own area, or whether you're going to enter that value yourself, and you should also enter in the height of lateral resistance. For the survival craft, you should enter in the heeling moment. So for example, if we have 6 lifeboats at 2 tons each at a distance of 10 meters, then we'd get 120 ton meters of heeling moment to compute the heeling arm. So they all come together into the overall probabilistic damage subdivision index S factor criterion. So now that that's set up, the remaining settings for analysis include defining which way we're going to heel the vessel. So we do have to choose whether we're going to heel in the port or starboard direction, or we can heel in both directions. If we heel in both, then the analysis will use the results for the worst case. If you're not sure which is your worst case direction, then you should use that option. You also use the trim command to set up the free to trim option. And in the preferences item in the edit menu, make sure the option for multiprocessor is turned on. That's the last item in this dialog box, and that will ensure that your analysis runs as fast as possible if you have a multi-core processor on your computer. Just above that is some settings relating to logging. You'll probably want to turn that on, and that will create a text file which is a log of all of the commands which are used and the intermediate results in the analysis. If you do have any problems, then you can often look through those intermediate results and see what the origin of the problems are. So those couple of settings then can be found in the preferences command from the edit menu, multi-core analysis and the logging of the results. Finally, when we come to run the analysis itself, then it's just the simple run command as usual to start our analysis. As the analysis runs, we can pause and continue our analysis. So you can see from the graphics at the top, the analysis is running for each damage condition. And if I bring the results window to the front, we can see that a number of analyses are running with the particular draft condition and zonal damage. The GZ curve is calculated for each, and then the properties are computed for the probabilities of damage of that zone, the properties of the GZ curve with that zone damaged, and then finally at the end the actual S factor and then the contribution to the accumulated attained index factor. So we'll leave that running and we'll go on to the next video to review results. Thanks for watching.